Okay, so we're going to look at different shapes of graphs. It's kind of important when you're conducting an experiment, you graph your data, you got to be able to analyze it. And a lot of times the data is not linear, like it was in the last example we did. If it's linear, it could be one of these two. Let's just skip ahead to this one. But if it's linear, you can see that as x increases in value, as the x value increases, the y value increases proportionately, right? So for every x, the y increases by the same amount. And in that case, the slope of the line, you know very well, is just y equals mx plus b. And that's pretty straightforward. Now that is kind of what we're trying to go for. This is what we want our graph to look like every time. So what if you plot your data and it doesn't look like that? So for example, what if the data looks like this? Okay, and in this example, what we see is that as x increases, what's happening to the y value? The y value is actually decreasing, right? So what we would say in this case is y is inversely proportional to x. And in this case, what we find is that what we can say, I'm going to just skip, I'll say this, y, you can say y is proportional to the inverse of x, or 1 over x. Okay, so this is something to keep in mind. This is an example of an inverse function. Okay, the next one we see here is as x increases, y increases, but it almost increases too fast, if you take my meaning. It's not linear. If it was linear, the line would look like this. That would be an equation of a straight line. And then we would end up with the y equals mx plus b again. But what we see is the y value increases sort of at a faster rate than the x value. You see over here, the y value is, each segment is going up at a higher rate. So, you can kind of think of this as an overachiever. Y is overachieving. Achiever. And in this example, what we would say is that the graph is y versus x squared. So it's like if you square your x value, then you would end up with a linear relationship. And then the last one we'll look at, the last sort of shape of a graph, is this one. And I would call this the underachiever. Because if you look at the x value and you ask yourself, how does the y value change? It doesn't rise as fast as the x value. So in this example, we would say that instead of y is proportional to x squared, we would say y squared is proportional to x. Another way to say that would be y versus, or is proportional to, the square root of x. This is, so you kind of get used to these shapes, and really it's honestly just about eyeballing. If you see a graph that looks like this, so if this is your graph, if you see a graph that looks like this, you would call that an inverse. Okay, if you saw a graph that looked like, so now the graph looks like this, it would be squared. If you saw a graph that looked like, and you can see how rough I'm being, right? If you see a graph that looks like, oops, we did that one. Let's say you see a graph that looks like this, that would be a square root, right? Okay, so those are the shapes. So now what we're going to do is go over to Logger Pro and put this all together and look at some actual data. All right, so now we're in Logger Pro, and I'm just going off of the worksheet you have. There was volume and there was pressure. So I've just pre-entered the data in here. I actually want to show you something here, and that's you can type the volume in. Volume is volume. The variable name was V. And over here, the units are cubic meters or meters cubed. So instead of doing this, or sometimes you see the hat notation, sometimes you have to use that, but in this case, they give the option of a subscript and a superscript. So you're going to say meters cubed. It just makes your graph look pretty. You can see it says meters cubed. I've also added a title. Something I wanted to tell you here is that you can just click if you just click on this axis, you can change what you're graphing. So you can choose to put pressure, volume on that axis and pressure on this axis, and you can see there's the graph. But we'll keep it the way it was. We'll keep it with volume here and pressure here. And we're going to talk more about how you know the difference. How do you know what to put on the X and the Y? And we'll talk more about that later. All right, so now we have this definite shape. Our first data point is way up here. So when X is very small, Y is very big, and then as X is increasing, you can see the Y value is actually decreasing. It's getting closer and closer to 0. So going back over to the shapes that we talked about earlier in the video, we can see that the shape it most closely resembles is this one. And what you notice is it's an inverse relationship, and so Y is proportional to 1 over X. So this is when we get into this cool aspect of Logger Pro. What we're going to do is not, I mean, you could do a curve fit, and this is how you do a curve fit, and it just asks you to guess what you think it is. And you have to pick. So like, for example, we could say, oh, let's graph an inverse. And you try the fit, and it looks pretty good, right? So you're really tempted to do a linear fit. There is a very, very definite reason why we don't do curve fits in this class, and I will talk about that more when we get into actual real world data. But for now, what I want to teach you is this technique called linearizing. So we've decided this is an inverse relationship. And so what I'm going to do is go into data, new calculated column. So what I'm going to do is create a column that is derived from calculating something to the to one of the variables. So in this case, what we learned in the over here is that Y is proportional to 1 over X. All right. So what I'm going to do, I can do one of two things, but what I'm going to do is take the inverse of X. So I'm going to call my new variable 1 over the volume. So I'm just doing that, and my unit, my short name, my variable, sorry, would be just 1 over V. And what would be my units? Well, my units will be 1 over and it was cubic meters, right? So 1 over meters cubed. Now, how do I calculate this 1 over? And this is where we get into here. I'm going to create the function. In this case, I can just go 1 divided by, and instead of typing volume, I'm going to choose volume. All it does is puts it in quotation marks so that the program knows that you're actually referring to a specific variable. So when I say done, nothing happens, except you'll notice that I've got this new column over here. So now I've actually got 3 columns, volume and pressure, the 2 I entered, and then I've got this calculated column based on taking 1 over the volume. So what I can do now is go over to my x-axis, and I think it's just off screen, but what you can do is, let me pull this up and then you can see it a little better. I can click on that and I can select 1 over volume. So now instead of pressure versus volume, I'm graphing pressure versus 1 over volume. And what's the first thing you notice? It is a beautiful, beautiful straight line. So what I'm going to do is a linear fit. And now what I have is this linear fit. And I will finish. Okay, so now what we have is a straight line, and we have all this data that they've given us here, which is really useful. We're going to take a look at it right now. So what we're going to do is we're going to use this idea of y equals mx plus b. But remember, my y is no longer y. My y is now pressure, right? So P. And my x is no longer x. My x is 1 over v. So when I go to put in my equation, what I'm going to say now is P equals, and we get our slope right here. It tells us it's 4, and my x is 1 over v plus b. Now, in this case, b equals 0. B equals 0. So my equation then is P equals 4 over V. Another way, 4 over V. It's a terrible 4. So 4 over V. Another way of writing this is P times V equals 4. Now, what I want you to think about is chemistry for a second. And remember what the equation you learned was PV equals nRT. Do you remember this? I know it's a lot to ask of you, but this nRT is just a constant, right? It's just a constant value. So what we end up with is PV equals a constant. And this is just whatever one of those laws it was. Boyle's law, Charles' law. You can ask Miranda. But the idea is this is how he did it. This is how Boyle or Charles, this is how they got their data. They did an experiment. They found a whole bunch of data, right? They found all this data, and then they graphed it and thought, how can I make this fit? And instead of, there was no curve fit back then. They had to do it the manual way, and this is how they did it. So just to recap, what we did is we took the volume, and we did 1 over the volume, and then once we got that, we graphed it, found a straight line, and we were able to determine that. So from our graph, just from this table of values, we were able to derive an equation. This is a powerful tool that we're going to use in this class.